Hello everyone. In this video we're going to be solving a Diophantine equation. We have a squared plus b squared equals a minus b to the third power. A and b are integers. That's why this is called a Diophantine equation. And we're going to be solving for a and b. So I'm going to start by setting a minus b equal to something. Since a and b are integers, a minus b will also be an integer, and I'm going to name that n. And once you do that, you're going to get another equation from here, which is a squared plus b squared equals n cubed. Awesome. We also know that a minus b is equal to n. Great. Now we're going to go ahead and square both sides here. And when we square both sides, we're going to get a squared plus b squared minus 2ab equals n squared. Now, this is the good thing about it. A squared plus b squared, we know what it is, right? It's equal to n cubed. So let's go ahead and replace this with n cubed. And from here, guess what we can do? We can solve for 2ab. Let's switch these around, and then we're going to get 2ab equals n cubed minus n squared. And then we can go ahead and divide both sides by 2. That's going to give us ab equals n cubed minus n squared divided by 2. So we got the product ab, and we know a minus b. Could we use those two things to come up with something meaningful, which is going to be actually a quadratic equation? And the answer is yes. Because a minus b is equal to n, I can go ahead and replace a with b plus n, add b to both sides, and then go ahead and substitute that here. That's going to give us the following. A times b, or b times a, which is b times b plus n, equals n cubed minus n squared divided by 2. Don't worry about the division by 2, because that is going to be taken care of in a little bit. But here's what I want you to notice. Let's multiply by b, or distribute, and subtract this. But to subtract, I'm just going to negate the numerator and add. Make sense? In other words, adding the opposite. Now, notice one thing. If you didn't notice, I'm going to go ahead and make it a little bit more clear for you, hopefully, that this equation is actually quadratic in b. Do you see that? So we can use the quadratic formula. Let's use it. B equals negative b. In this case, of course, b is the coefficient of b. If you know what I'm talking about, negative n plus minus the square root of b squared, which is n squared, minus 4ac. This is where the 2 cancels out, and we end up with 2 times n squared minus n cubed. And all of that is divided by 2. Awesome. Let's simplify this. N squared minus 2n squared plus 2n cubed is going to give us negative n plus minus the square root of 2n cubed minus n squared. All of that is divided by 2. Now we can further simplify this by taking out n squared as a common factor. And then if you square root it, it's going to become n. But let's go ahead and not skip any steps, and first write it this way. And then because we have a plus minus sign, it wouldn't matter. We can take it out. Awesome. So that's b in terms of n. But since b is an integer, a is an integer, n is an integer, everything is an integer, we can go ahead and do the following. 2n minus 1, the square root of that needs to be an integer. So 2n minus 1 needs to be a perfect square. Let's go ahead and call that k squared. Awesome. So 2n minus 1 equals k squared. And as you know, 2n minus 1 is odd. It's kind of odd, right? So that means k squared is odd, and that implies that k is odd. Nice. Since k is odd, I can write k as 2c plus 1. This is number theory. Welcome to number theory. If you haven't seen a problem like this before, we make a lot of substitutions. Now, here's the fun part. If k is equal to 2c plus 1, then 2n minus 1 is going to be, because k is equal to that, and n is equal to 2n minus 1 is equal to k squared. So I'm going to replace this with k. It's going to be 2c, or not 2c. Hopefully you see what I see. It's going to be that. Now let's expand it. 4c squared plus 4c plus 1. Okay, this is for you to see. And then add 1 to both sides. 4c squared plus 4c plus 2. Beautiful. And this makes sense because these are all integers, and we can divide both sides by 2. And guess what that's going to give you? That's going to give you n in terms of c. And that's very critical. Now, let's save that for now and focus on b, because we're looking for a and b, right? What is b? According to our equation, if you remember, was negative n plus minus n times the square root of 2n minus 1, which is the square root of k squared, which is k. So in other words, we can write the b as negative n plus minus nk divided by 2. And now from here, if you do all the necessary substitutions, replace k with this, replace n with that, you're going to get the 2 results. Okay, I'm going to spare you the trouble. And b values are going to be like this. C times 2c squared plus 2c plus 1. That's one of the b values. The other b value is kind of weird because it contains a negative factor, like the opposite of c plus 1. But the second factor is going to be the same. That's important because we're trying to parameterize this equation. You know what that means? I'll tell you at the end. Okay? So these are the b values, but we still need to find a, right? So let's go ahead and look at 2 cases. I can call this case 1 and call this case 2. So let's start with case 1. b is equal to c times 2c squared plus 2c plus 1. By the way, don't distribute it. It's better that way. Now, remember, a is equal to b plus n. So a can be written as b, which is this, plus n, which is 2c squared plus 2c plus 1. Do you remember? That's where the n comes from, actually, right here. Look at that. Awesome. Now this is nice because if you write this and multiply by 1, then you have a common factor. From here, a becomes c plus 1 multiplied by 2c squared plus 2c plus 1. So we got a and b values. If this is a, and then this is b. Awesome. That's our parameters. Let's go ahead and take a look at case 2. If b is equal to negative, remember the negative weird factor. From here, to keep a long story short, you're going to plug it in just like before. b plus n, and then so on and so forth. And from here, you're going to get a equals negative c times the same factor. Notice that how they switch around nicely, a and b values. And that's going to be another pair with parameters. Now let's go ahead and take a look at some special cases. Let's take the first one. A equals c plus 1 times 2c squared plus 2c plus 1. And b equals c times the same thing. And now I'd like to replace c with 1 because I can pretty much use anything for c. If c is equal to 1, from the first one I get a equals 10 and b equals 5. Maybe I should just use a comma because they don't necessarily imply each other. And then if I use the second one, this is case 1. If I use case 2, this is case 1. If I use case 2, I get a equals negative 5, and I want you to pay attention to this, and b equals negative 10. Notice how a and b switch around nicely. So we got 2 ordered pairs, and obviously there are infinitely many more. Because by parameterizing, meaning that we use a third variable, so that when that variable changes or varies, our a and b values are determined. Make sense? Now let's go ahead and look at something really cool. Actually, a couple things. First of all, you can solve for b using the cubic formula, right? Obviously, but that's not very pleasant, is it? Take a look, some of particular values, and this is the graph. Look at the symmetry. What do you think this line is, right? that is y equals negative x. You see the symmetry, and remember the ordered pairs. This is just another graph by Wolfram Alpha. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.